Warm welcome and greetings to my dear students and friends. Today we are going to see about the method of deflection using conjugate beam method. It is used to find the slope and deflection of a beam with a different loading condition like UDL, UVL, and also the point load or concentrated load, and also the flexural rigidity of the beam, that is capital EI, is varying from section to section. This method is very useful to find the slope and deflection of the beam. So conjugate beam is nothing but a fictitious beam with a loading on the beam. You draw the free bending moment diagram of the conjugate beam with a simply supported condition, and this bending moment divided by the flexural rigidity of the beam, that is M by EI, that is called as the conjugate beam. Simply supported beam divided by the corresponding the moment divided by EI value, that is called as M by EI, that is called as a conjugate beam. So this beam application is used to find the slope and deflection, the different load conditions, and if it is a various type of loading. Already I have told you UDL, UVL, and also the point load and its combination. With the flexural rigidity, EI is also varying. You draw the free bending moment diagram of the given beam. The next step, you draw the M by EI diagram. So for M by EI diagram, you have to find the shear force wherever it is required. So that shear force, capital F or capital S, so that gives the slope of the beam at any section. And how to find the deflection of the beam at the required point of the conjugate beam, that is M by EI diagram of the given beam. You find the bending moment wherever the section is required. So at the middle point or L by 4 or 3 by 4th of L of a conjugate beam. So that the bending moment at the required point will give the deflection of the beam. So whatever be the slope and deflection you are finding, so for example, for a simply supported beam with a point load at the center of the span, you know the deflection at mid span is maximum, that is equal to WLQ by 48EI. If you are using any of the method, either double integration method or moment area method or conjugate beam method, you have to get the same answer. That is the deflection at mid span for the simply supported beam with the central point load is WLQ by 48EI. So in the case of conjugate beam, you are applying the moment at the required point at the midpoint of a beam. Then you will get the deflection. Suppose I want to find the slope at the support ends. You find the shear force at the support end. So if it is symmetrically loaded, so here it will be of W L squared by 24 EI. So you will get for the simply supported beam. You have to get the same answer by comparing other method in the case of the conjugate beam method. So it is the simplest method, but only thing is you have to be able to draw the bending moment diagram for a simply supported condition. After that, you draw the M by E diagram. For the M by E diagram, you find the shear force that gives the slope. You find the bending moment wherever the deflection is required. At that point, you are finding the bending moment that gives the deflection. So in the case of cantilever beam, with the same flexural rigidity EI with the span L, you have to get W L square by 8 EI, the deflection. Whatever be the types of method of slope and deflection you are following, you have to get the same answer. So in this case, that is a simplest method, provided if you are able to find the shear force and bending moment of MIA diagram. And also you can have the condition of the different varying of the flexural rigidity of the beam. That is the product of Young's modulus and the moment of inertia about the neutral axis. That is E into I. So if you are able to find for any type of sections, you can definitely easily find the slope and deflection of this conjugate beam method. So this is the procedure to find the slope and deflection for the given conjugate beam. But only the condition is it is used for a different loading condition, and as well as the EI is varying from section to section. So then only this method is very simple. Otherwise, it will be complicated. So this is called as method of conjugate beam to find the slope and deflection. So thank you very much for patient listening, and we can see in the next video lecture. God bless you all. வாழ்க வையகம், வாழ்க வளமுடன்.